Well, good morning, everyone. I welcome you all to this fourth day of learning the machine learning using WEKA. And I can see that only 6 participants have joined so far. So I believe that we can wait for another couple of minutes so that more can rope in. So I think we can start now. And as per the outline of the faculty development program on machine learning using WEKA, today is the day 4. And today we are going to learn about a very important machine learning functionality, that is cluster analysis. So as you can see in this picture, that cluster analysis or clustering is a type of a machine learning technique that partitions the data into segments based on their features. Like if I talk about the feature, say color, then it partitions this whole data set into 4 different clusters. One is green, another is somewhere red or orange, then the next is blue, and the other is green. So by color, by this one feature color, I can cluster this data into segments. I can partition this data into clusters, or on the basis of shape, I can have 2 different segments for this data, and on the basis of size also, I can have 2 different clusters of the entire data set. So first part of the definition of cluster analysis is that it is a type of a machine learning technique that partitions the data into segments, into small segments on the basis of the features or the characteristics. Now, if we look at this another picture, we can have a broader view of what we have said just now, that this partitioning, and this will also cover up the second part of the definition, that when I talk about the partitioning or segmenting or clustering the data, what do I mean? My meaning with this is that this was the entire data set consisting of all the objects, and now my objective or my task is to divide this data into a number of clusters. There can be 2 clusters, there can be 3 clusters, or there can be many clusters. It is entirely up to the user, and it actually comes either from the literature or from the data set, that how many clusters should be there based on the data set which is available. Now, the second part of the definition says that the clusters should be made such that the objects within one cluster or one segment or one partition are most similar, and the objects between 2 different groups of clusters should be most dissimilar. Like the object, this is one cluster, this is another cluster, this is the third cluster. So objects that are within one cluster should be most similar to each other, and the objects of this cluster 1 should be most dissimilar to the object of this cluster 2. Or on the other hand, in a different way, we can say that the intra-cluster or within cluster similarity should be maximum. Intra-cluster similarity is the similarity between the objects of one cluster. So this is, we call it intra-cluster similarity. So intra-cluster similarity should be maximum because they are most similar, and inter-cluster similarity, that is similarity between the objects of two different clusters, should be minimum. So intra-cluster similarity should be maximum and inter-cluster similarity should be minimum. Now, as we say that the intra-cluster similarity is maximum and the inter-cluster similarity is minimum, by this we mean to say that we can define it with the help of a distance function. I can support my statement with the help of a distance function. By distance function, I mean that all these objects are there on a plot at some distance, because if the distance between two objects is 0, then both these objects are same. So iska matlab all these objects 1 2 3 4 5 6 7, all these different objects are lying or plotted on this area at some distance. Now this distance of between the objects of one cluster should be minimum. That is why if this distance, as you can see here, the distance between these two objects should be minimum, then we can say that this distance is minimum, therefore they are more closer to each other and they are more similar to each other. And then yes, on the basis of this, because ultimately we have to have some basis to keep the objects into one cluster or to keep the objects into different clusters. So what is the basis for that? The basis for that is the distance function. So from where here we can have a broader look at the distance function. The objects of one cluster should have the minimum distance between each other, and the objects of different clusters should have maximum distance between the clusters between each other. So this is how we can have a look at the definition of clustering, that the clustering is a machine learning technique to partition the data into segments. This was initially, it was all one data set, and then by applying the clustering technique or the partitioning method, we have clustered all the objects into 3 partitions based on their features, some of their features or characteristics. Like there can be one feature, as in this case there is only one feature, color, and in the next case there is only one feature like shape, or there can be a number of different features. So we will be learning all this with the help of examples. Now this partitioning on the basis of the features such that the intra-cluster similarity is maximum. The objects within one cluster are most similar to each other, and the inter-cluster similarity is minimum. That is, the objects within the different clusters must be most dissimilar to each other. So therefore, in some way, clustering is similar to classification, because in both these techniques we use to classify the data. However, on the other hand, we can say that clustering is also different from classification, because in clustering, we know nothing in advance. We only have the input attributes. We do not have the input variables that are labeled. We do not have an output attribute. So therefore, clustering is a classification which is unsupervised because the data is not labeled. However, जो क्लासिफिकेशन है दैट इज अ सुपरवाइज्ड लर्निंग, बिकॉज इनपुट वेरिएबल्स के साथ साथ हमारे पास ऑल दीज इनपुट वेरिएबल्स आर लेबल्ड, एंड विद ऑल दीज इनपुट वेरिएबल्स वी आल्सो हैव अ आउटपुट वेरिएबल. So now the question is a very important question that we should focus upon, is that why do we need to cluster the data? Why cannot we keep the data just as it is? Why do we need clustering? What are we going to get out of it? So now to answer this question, let us look at another picture, wherein suppose a manager or a business analyst or a data analyst is worried about the launch of a product. He wants to know that before or after the launch of the product, how should he promote the product, or what is the target customer who is going to buy the product. So suppose the manager is thinking of that who should buy my product, this is the product, and who is my target customer who is going to buy this product, so that I can increase the profit making of an organization, so that I can make maximum money by launching of this product. So now this is the entire data set, this is the entire population of people, and we should all know that every product is not meant for everyone. So this is the entire population. So clustering of this entire population into different type of people, this is one category of people. Maybe some product is made for females, some product is meant for males, some product is like categorized on the basis of gender, some is meant for children, some is meant for infants. So this is the in the entire population of the data set, these are the different categories of people. And after this clustering, after this proper well segmentation of the data only, the manager is happy to know. Here you can see in this picture the how happy the manager is to know that yes, this is my target audience and this is my product, and if I will sell this product to this audience, then only I can increase the profit making of my organization. So therefore, because we can well understand that the products are designed, manufactured and launched on the basis of many factors, like what is the customer type, what is the gender, what is their demographics, what is the climate. Some of the products are best sold in winters, some others are best sold in summers. So there are many different factors that are attached with the launching of a product. So therefore, it is very important for us to learn the type of the customer of an organization that an organization is catering to in order to optimize or increase the benefits of an organization. Now, to further understand this concept of target marketing or selling, let us take the example, let us take some example which we daily experience in our routine life. So let us take up the example of a university or a college or a school system, where in every class there is a lot of diversity in students in terms of their intelligence, their behavior, or their psychology, or maybe where they come from, or the families they belong to. So there are the different types of students in a class, and all of these different types of students have to be dealt with differently. So they have to be first clustered well, and then based on different types of the students, they have to be dealt with differently. Like a group of some students are maybe psychologically weak, and therefore they need maybe more mentoring. Some of the other students may be academically weak, so they need more extra classes. Not every student needs extra classes. Another group of students may have some behavioral issues, so they should be asked to see the counselor, because we do not ask every student to go to the counselor. And some another group of some students may be academically brilliant, so their energy or the energy of such students should be channelized accordingly by giving them some extra projects or some extra work, or maybe by involving them with some co-curricular and extracurricular activities, and also like we do by making them a part of the UCA batch. So this is how we can understand well the significance of the application of clustering and how it can largely impact the overall education of a system in a positive manner. Now, not only education, if you talk about any business area or an organization that offers products and services like retailing or banking or insurance or maybe hospitality or tourism, or maybe health sciences, or maybe medical sciences, or maybe biological studies, wherein you need to classify the plants and animals on the basis of many factors, or maybe web discovery system, each one of these areas needs some kind of segmentation for targeted action. So this can help them to know their customers better and to perform an appropriate fact-based action, not just random action ki okay, just do it just for the sake of doing. Just for the sake of doing. No, it will help us to make the appropriate fact-based action, to have a better return on investment, to have more customer relationship management, to have increased or improved customer retention, and to finally optimize the goal and the overall business process. So therefore, this is the overall, the entire introduction of clustering, and with this we can well understand the significance and the importance of a clustering algorithm in context to machine learning. So with this, let me take up the contents that we are going to cover in today's session. We have already discussed the concept of clustering. Then we will be discussing the distance metric. Then we'll be learning about the k-means clustering, because the agenda of today's lecture is k-means clustering. We'll be doing a couple of examples to support our answer. Then we will move on to the implementation part. We will be implementing clustering algorithm. We will be implementing clustering algorithm using WEKA. And then we will be analyzing the results by identification of the centroid for each cluster, the concept of within some cluster sum of squared error, then identification of the optimum number of clusters, that how do we actually identify that how many number of clusters should we keep. Then we will also learn to classify the unlabeled data, because so far we all know that the only the labeled data can be classified and the unlabeled data can be clustered. But here towards the end of this session, we will also learn to classify the unlabeled data, but then we will learn to add the clusters through the data set. Then we'll learn to apply the classification algorithm, and then finally we will learn to prune the decision tree. Then if the time will permit us, we will also today try to learn the use of the knowledge flow, because so far we have been working with the explorer only. So we will also try to make use of the knowledge flow to design a classification model, and then finally we'll be ending up with the exercise. So now the point is that we have already had the introduction of clustering, and we have learned that how this clustering and what is actually the impact and the significance or the importance of clustering. Now the point is that how do we do this? ये होता कैसे है? How do we perform clustering? How do we keep from the entire data set some of the objects or the instances in one cluster, and how do we put some of the other instances in some another cluster and in some another cluster? So how does it all happen? So for to understand this, we need to understand the role of a distance metric. So distance metric play a very important role in designing the clusters from the entire data set. So distance metric, as the name suggests, बहुत ज्यादा theory हम नहीं करेंगे, overview करेंगे. So distance metric का मतलब है कि distance between the elements of a set, distance between two objects. So ये जो हम distance निकालते हैं, there are two different types of distances. One is actually distance based and the another is correlation based. So there is no empirical evidence that is available to state that which type of a distance measure is the best, but actually the classical distance measure is Euclidean distance or Manhattan distance. Other measures are also available, like correlation based measures are also there, wherein they use Pearson or other correlation coefficients. But the type of distance measure that should be selected is entirely based on the type of the data and the research question. For example, if I take the example of the correlation based distance measure, so it is usually used in the gene expression data analysis, जहां पर हम Pearson correlation use करते हैं, और usually for a larger picture, correlation based distance measure functions should be used in हाई डायमेंशनल डेटा, जहां पर बहुत सारे फीचर्स और एट्रीब्यूट्स हैं, और जितने नंबर ऑफ, क्योंकि बिकॉज देयर हैज टू बी अ बैलेंस बिटवीन द नंबर ऑफ फीचर्स एंड द नंबर ऑफ इंस्टेंसेस, number of attributes and the number of rows. So always the number of rows must be with respect to the number of instances. So those that are very high dimensional data, wherein the number of attributes and the number of columns and the number of instances are quite large, there we use the correlation based methods, and otherwise the most classical standard methods are Euclidean distance and Manhattan distance. So today we'll be having a broad look at the different types of distance metrics, and then we will also learn the k-means clustering algorithm. So distance metric, as I have already told you, is the distance, will give you the distance between two objects for, and it will give you the distance for all the elements of the set. So this is the formula for Euclidean distance. Euclidean distance between two objects. The first object is having xy and the second object is having ab. Then it is the square root of, how do we find it? X minus a ka square root of x minus a ka square plus y minus b ka square. So for example, between two points having these two coordinates, like first point's coordinate are -2 and 2, and the second point's coordinates are 2 and -1, then the Euclidean distance can be found out by -2 ka square plus 2 minus -1 ka square ka whole square root of the entire this thing. So this comes out to be equal to 5. So this is how we find out the Euclidean distance. I will not be getting into more details. I'll be just giving you the formulas of all the Euclidean distances. एक example मैं आपको बता रही हूँ कि suppose we want to find out the distance between these three persons. So these are the persons on this side, and these are the variables. So these variables can be, there are therefore two variables. The first variable can be the age of that person, and the second variable can be the income of that person. So this we can have in thousands. So the for that matter, how can we read it? That the person 1 is having age 30 and income is 70,000. Person 2 is having age 40 and income is 54,000. Person 3, for person 3, age is 80 and the income is 50,000. So how can we find the Euclidean distance between all these persons? So first we will find out between person 1 and person 2, then we will find out between person 2 and person 3, and then we will find out between person 1 and person 3. I know that the theory may bother you a bit, but then you have to realize that there is nothing more practical than a good theory. So we cannot simply jump onto the practical before actually having the theoretical idea of the concept. So therefore, I am telling you the broader view of the entire theory, which is behind the algorithm that we are going to implement through WEKA. So therefore, this is how we use it. So between person 1 and person 2. So how do we do it? First, the age 30 minus 40 ka square, then the second variable 70 minus 54 ka square, and then the square root of both these things. So this comes out to be 18.86. Similarly, we can find between person 1 and 3, this comes out to be 53.85, and then we can find for between person 2 and 3, and this comes out to be 40.19. So with these distances between person 1 and person 2, person 1 and person 3, person 2 and person 3 respectively, we can see that we can correlate that which two persons are closely related, which two persons are more similar and which two persons are most dissimilar. So there we can see that 1 and 2 are having the smallest distance between them, and 1 and 3 are having the largest distance between them. So 1 is most similar to 2 and 1 is most dissimilar to 3. So this is how we actually read it, and this is how we find out the differences. So there are other distance measures as well, like Manhattan distance. The values may be different because of the calculation and the formula, but the overall result will largely be the same. So for example, Manhattan distance is the most easiest of the way to calculate it, because we take care of we bother the absolute differences. So the same thing if we do with the help of the Manhattan distances, like between the first persons, between person 1 and person 2, if we want to find out the distance between person 1 and person 2, how do we do it? First, the age of person 1, and then the age of person 2, then the income of person 1, and then the income of person 2. So this is how we can subtract it, and we can take the absolute value and can finally get the calculation. So similarly, we can find it out between person 1 and 3, and then similarly we can find it out for person 2 and 3, and then we may find here that the results are largely be the same. The values are different, but the result is the same, that the person 1, this distance is minimum, this distance is maximum. So we can say that person 1 is most similar to person 2, and person 1 is most dissimilar to person 3. Similarly, Chebyshev distance is also there. Then this actually takes the maximum value of the 2. So if suppose this value is 10 and this is 16, so it takes the result will be 16. So it takes the maximum value of both. So here also the values may differ, but the result is same. This is the smallest distance, this is the largest distance. So person 1 and person 2 are most closely related, and person 1 and person 3 are most dissimilar to each other. Now let us get down to the major clustering algorithms. There are different types of clustering algorithms, like some are the partition based, some are the hierarchical methods, then are the density based, then are the grid based, and many other different types of clustering algorithms are there. So the partitioning based methods are actually that we have just learned, that which actually partitions or segments the data into different clusters. Hierarchical method भी यही करता है, but it actually generates the hierarchy of clusters. So therefore the difference between the partition and hierarchical method is that the hierarchical method will build a nested series of cluster, whereas the partitioning method will generate a flat set of cluster. So partitioning method एक flat set of cluster, all the clusters will be at the same level. However, the hierarchical method will give you or generate a hierarchical nested series of clusters. So then there are density based methods, then are grid based methods, but our main focus is on k-means clustering, which is a partition based method. So this is the algorithm or the steps of k-means clustering. Without reading for the steps of these clustering, let us try to understand or comprehend the concept with the help of an example. So as you will go through the example, you will automatically get to know that what are the various steps in the k-means clustering algorithm. So this is the first example, wherein you can see that if I read out the statement that suppose the visitors visiting a website are to be grouped on the basis of their age. इसका मतलब this data is related to the age of the visitors, and they are the visitors of a website, and we want to group them in a different clusters on the basis of their age. तो इसका मतलब हमारे पास सिर्फ एक वेरिएबल है. We have the values for only one variable, and they seem to be some 19 to 20 instances. So इसका मतलब 19 से 20 कुछ customers हैं जिनकी age, respective age of these customers are given, and we have to group them into 2 or 3 or 4 or many clusters. So it is entirely up to the user that how many clusters, how many partitions the user wants to create. इसके अलावा हमारे पास we also have a technique to decide that what is the optimum number of clusters, that we will come back at the time of the implementation. So here the initial step is to read the data, and suppose let us decide to have k number of clusters and k is equal to 2. इसका मतलब हम 2 clusters बनाना चाहते हैं, and then after deciding k, that is the number of clusters, we have to choose the seed record. Seed record का मतलब कि हमारे पास 2 seeds हैं, 2 clusters हैं, and we want to choose the initial record कि which cluster or which instance we want to keep as a centroid initially, because the entire thing is based on the concept of centroid. तो हमने initially हमने मान लिया कि जो पहला cluster है उसका centroid 16 रहेगा और दूसरा cluster है उसका centroid 22 रहेगा. We can choose any initial centroids, like we can say that first is 19, the second is 65. Any cluster centroids can be chosen as the initial seed record. So now let us see And then the next step, first step is to decide the number of clusters. Second step is to choose the centroid for cluster 1 and cluster 2. Only in the first step you will have to choose the centroid. For rest of, because K means clustering is an iterative process, so you have to choose the centroid only in the first step. For all of the rest of the steps, the centroid will be calculated on the basis of the average. So सिर्फ पहली बार आपको चूज करने हैं, और कितने चूज करने हैं, उतने ही चूज करने हैं जितने नंबर ऑफ क्लस्टर्स आपने डिसाइड किए हैं. उसको चूज करने के बाद then you will have to find out the distance of every record or instance from these centroids, from this centroid also and from this centroid also. So you have to have the distance of every record from each centroid. So now let us see, I've already calculated it for you. So let us see how we do it. So suppose the 16 is the centroid for cluster 1 and 22 is the centroid for cluster 2. So, and these are all these instances that are given in the first column. So centroid 16 and instance key value is 15. So the distance is 1. Centroid is 22. The value of the instance is same, 15. So for every instance, we have to calculate the distance from the first centroid, that is first cluster, and distance from the second cluster. की मतलब हर record पहले क्लस्टर से कितना दूर है, या कितना डिसिमिलर है, या कितना सिमिलर है, और दूसरे क्लस्टर से कितना दूर है, या कितना पास है, या कितना सिमिलर है, या कितना डिसिमिलर है. This distance is actually telling us that how close a record to a cluster is. So this, as we can see here, 15 is having a distance 1 with respect to cluster 1 and distance 7 with respect to cluster 2. So this gives us the entire picture. Iska matlab the first record is more similar and more close to cluster 1 than to cluster 2. So similarly, we find out for the second is the record value of the record is same. So the this distance will also be the same. The third is obviously because this is chosen to be the centroid and the value of the record is also 16. So this will be 0 and this is 6. So this way we will calculate the distance of all the records from both the centroids. Now the next step is to do the cluster assignments. So abhi hame cluster assignments karni hai, and very simply we can do the cluster assignment here. Like if we look at this first record, this is more close to cluster 1 because the distance with cluster 1 is 1 and distance from cluster 2 is 7. So this is assigned to cluster 1. Similarly, the next record is also assigned to cluster 1. Next record, because this is smaller than this distance, so this is also assigned to cluster 1. In the next record, you can see that the distance from both the clusters is similar. In this record, we can see that the distance of this record or distance of this object from both the clusters is similar. So this can be put in any cluster initially. So I can choose to put in cluster 1 or I can select to put in it in cluster 2. So I have selected to put in cluster 2 for example. अगला रिकॉर्ड भी दोनों का डिस्टेंस सेम है तो will be there, can be there in cluster 1 or 2. मैंने इसको cluster 2 में डाल दिया. For the next record, distance from cluster 1 is 4, distance from cluster 2 is 2. So therefore it will go to cluster 2. The next will also go to cluster 2. The next on the basis of this distance will also go to cluster 2. The next will also go to cluster 2. On the basis of the distance, all these records will go to cluster 2. So there we can see that after these cluster assignments, first three records with the value 15, 15 and 16 belong to cluster 1 and rest of all the records belong to cluster 2. So this is how we can see that two clusters are formed. Initially there was only single data set और अभी हमारे पास दो clusters आ चुके हैं. Two clusters are formed with these values. So in the first cluster there are 3 records and in the rest of the records are there in the second cluster. So now the next step is to calculate the centroid. Initially फर्स्ट ऑफ ऑल हमने इसको सिलेक्ट किया था. अब इसके बाद हमारे पास रैंडम सिलेक्ट करने का कोई प्रोविजन नहीं है. वी विल सिंपली कैलकुलेट द सेंट्रॉइड एज the average value of all the instances of a particular cluster. So first of all, the first cluster is having 15, 15 and 16. Because this is numerical data, so we can easily find out the average value. So usually, largely, mostly clustering is performed on the numerical and the continuous data. It can also be performed on categorical data, but abhi we are referring to only performing clustering on the continuous variable. Fine. So ये continuous है, easily इसका centroid निकल आएगा. So new centroid, previous centroid was 16 for cluster 1. The new centroid for cluster 1 is 15.33, and similarly we can find it for cluster 2, and then the new centroid as an average of all record all these values. So the new centroid for cluster 2 is 36.25. So as we go further, we can again, we have got the new centroid for cluster 1 and the new centroid for cluster 2, and the task is the same, that we have to find out the distance of every instance from cluster 1 and from cluster 2. Distance of every instance from the centroid of cluster 1 and from the centroid of the cluster 2. So this is cluster 1, cluster 2, and this is how we will find out the difference from cluster 1 and cluster 2 with respect to all the instances. Now again the same task has to be repeated. We will have to see that which of the distance is smaller in order to assign to a particular cluster. So by choosing that to which it actually should belong. So this is very less and this is quite large. So quite obvious that this should belong to cluster 1. This 15 is closer to cluster 1 and very far from cluster 2 centroid. So therefore it should belong to cluster 1. Here also between these two distances it should belong to cluster 1. Now 19, which we earlier put into cluster 2, we can see the distance, it should belong to cluster 1. 19 again should belong to cluster 1. Even 20 now belongs to cluster 1. Again 20 should belong to cluster 1. 21 is also having a smaller distance as compared to the centroid of the cluster 2. So therefore it should belong to cluster 1. Again 22 should also belong to cluster 1. And as we come down to the instance having a value 28, we can see that its distance from the centroid of cluster 1 is higher as compared to the centroid of cluster 2. So therefore it should belong to cluster 2. So all these are arranged in an order. So therefore we can see that now we are going to get the values smaller on the side of the cluster 2 centroid as compared to on the side of the cluster 1 centroid. So therefore all these clusters are having values smaller than that in the cluster 1. So therefore all these should belong to cluster 2. So this way we can observe that in the next iteration we can see that new cluster assignments have been made, and such that the first cluster is having these many instances and the second cluster is having these many instances. So again the centroid will be calculated, and the new centroid for cluster 1 is the average of all these values of all these instances, and this centroid 2 is the average of the instances of all these values. So in a similar fashion we will do it again, and we will see that I will not repeat to tell you that how do we calculate these distances now, because this difference we can easily calculate. So now let us look at the cluster assignments, and as we go down to the number of instances we can see that 28 was in the previous step 28 was initialized or assigned to cluster 2, but now this instance 28, one cluster assignment has been changed in this iteration, that is 28 now belongs to cluster 2 rather than now belongs to cluster 1 rather than cluster 2. So these are the new assignments that we have got and the new centroid. जब भी हमें कोई भी नई assignment मिलेगी, we'll have to again recalculate the centroid value. So centroid will again be recalculated, and the new centroids we have got for both the clusters. So now let us look at the cluster assignments. बाकी सब चीजें हम कर सकते हैं. So if we look into the cluster assignments, we can see that yes, now this is giving us the same result as per the cluster assignments in the previous step. In the previous step also, the cluster assignment, the cluster 1 was having the records from 15 to 28, and the cluster 2 was having the assignments from 35 to 65. And in this step also, so there we should stop. So because no object has shifted from one cluster to another cluster, so therefore no change has been found between iteration 3 and 4. So this is the step where we have to stop repeating the procedure. So this way we can see that this is the final cluster assignments. Cluster 1 has been assigned with all these objects, and cluster 2, initially हमने देखा था कि cluster 1 में सिर्फ 3 objects थे, और finally there are so many objects are there in the cluster 1 and in cluster 2. So then we can have a plot to have a more clearer view of this. So this is how we do it. This is actually simple k-means clustering. Initially, we decide the seeds and the seed record, that is the centroid. Seed is the number of clusters, centroids are the initial cluster points, and then we find out the distance of every object from every centroid. दो centroid हैं तो 2 से, 3 है तो 3 से, 4 cluster हैं तो 4 से. So every centroid से we will find out the distance, and based on this distance function, whichever distance is smaller, whichever record is having a smaller distance with respect to the centroid of any of the cluster, that will fall in cluster 1. The rest of others will fall in cluster 2 or 3 or 4 and so on. Now let us look at another example. Example same hai, iteration same hai, calculation same hai, but this example has been taken to for a different objective जो मैं अभी आपको बताने वाली हूँ. तो अभी हमें सिर्फ ये देखना है कि पहली चीज तो यहाँ पर हमें ये चीज डिफरेंशिएट करनी है कि here we have some of the instances, 10 instances are there, but now the instances, they do not only have one attribute, that is age, rather they will be clustered on the basis of 4 different parameters, that is the marks in quiz 1, marks in mid semester examination, marks in quiz 2, and marks in the end semester examination. So with this we can understand that there is not just one attribute on the basis of which the objects can be clustered into various partitions or groups, rather there can be a different number of factors or parameters on the basis of which the assignments can be done. So abhi isme bhi hame kya karna hai, suppose we want to go for 3 number of clusters, and then we'll have to choose 3 seed records, और seed records हमारे पास हमने randomly कौन से ले लिए. Let us suppose to take the first 3 records as the 3 seed records, क्योंकि हमें 3 number of clusters बनाने हैं. So these are the seed records, and let us go for the calculation. तो थोड़ा सा बिल्कुल यहाँ पर देखेंगे क्योंकि कैलकुलेशन विल बी अ बिट टिपिकल, कॉम्प्लेक्स, क्योंकि यहाँ पर नंबर ऑफ एट्रीब्यूट्स बढ़ गए हैं. So ये हमारे seed records हैं. These are the seed records. This is the seed record for cluster 1. This is the seed record for cluster 2. This is the seed record for cluster 3. Irrespective of the number of attributes, same तरीके से हमें distance find out करना है. Student 1 का distance from cluster 1. तो student 1 का, क्योंकि यही तो हमने cluster 1 का centroid बनाया था, तो obviously student 1 का difference from cluster 1 will be 0. मैनहट्टन डिस्टेंस हम यूज कर रहे हैं, एब्सोल्यूट वैल्यूज हमें मिल जाएंगे और इट विल बी बिट इजियर फॉर यू. अदरवाइज के मींस क्लस्टरिंग के लिए बाय डिफॉल्ट यूक्लिडियन डिस्टेंस ही यूज होता है. ठीक है. सो सिमिलरली स्टूडेंट 1 का डिफरेंस distance from cluster 2 will be calculated like एक सिर्फ आपको बता रही हूँ, 8 minus 6 plus 20 minus 18 plus 6 minus 7 plus 45 minus 22. So the पूरी value will be 8. Similarly, student 1 का distance from cluster 3. So इस तरह से हमने ये सारी values निकाल ली और हमने यहाँ पर ये देखा कि इन तीनों distance में से student 1 का distance cluster 1 से सबसे ज्यादा कम है, so it will belong to cluster 1. Obviously ये seed record है, it will belong automatically to cluster 2, and this is also seed record, will belong automatically to cluster 3. Similarly for rest of the records, student 4 के ये distances आए हैं, सबसे छोटा distance 14 है, so it will belong to cluster 3. Student 5 के केस में सबसे छोटा distance ये है, so will belong to cluster 1. Student 6 के record में this is the smallest distance, so will belong to cluster 1. Student 7 के केस में this is the smallest distance, so it should belong to cluster 1. Student 8 के case में this is the smallest distance, so this should belong to cluster 2. Student 9 के case में the smallest distance is like 18, so this should belong to cluster 3. And student 10 के case में the smallest distance is 5, so therefore it should also belong to cluster 3. So after the cluster assignments, we will get to know that there are 4 students in cluster 1, like 1, 5, 6 and 7. And there are 2 students in cluster 2, that is 2 and 8. And there are 4 students again in cluster 3, that are 3, 4, 9 and 10. So these are the cluster assignments. अभी करेंगे क्या, फिर से क्लस्टर सेंट्रॉइड देखना है, निकालना है, तो वो कैसे निकालते हैं? क्लस्टर सेंट्रॉइड अब हमें कैसे निकालना है? एक का निकाल के बता रही हूँ, बाकी सबका हमें पता चल जाएगा. सो क्लस्टर 1 में कौन से रिकॉर्ड्स है? 1, 5, 6 एंड 7. सो रिकॉर्ड 1, 5, 6 एंड 7. क्विज में इसके कितने मार्क्स थे? मिड सेमेस्टर में कितने? क्विज 2 में कितने? और एंड सेमेस्टर में कितने? सो एवरेज ऑफ all these, so this is average of quiz 1 में student 1 के 8 मार्क्स थे, student नंबर 5 के 9 मार्क्स थे, student नंबर 6 के 7 मार्क्स थे और स्टूडेंट नंबर 9 के 9 मार्क्स थे. सो एवरेज ऑफ ऑल दी स्टूडेंट नंबर 1, 5, 6, 7 is 8.25. Initially it was 8, now the centroid has been changed to 8.25. Similarly for MSc, so यहाँ पर देखने वाली बात ये है, हम implementation, when we will be doing the implementation of the algorithm, then also we will get to see that the centroid will be with respect to every cluster and with respect to every attribute. तो अगर हमारे पास 3 क्लस्टर्स हैं और 4 एट्रीब्यूट्स हैं, तो टोटल हमारे पास कितने सेंट्रॉइड्स आएंगे? दिस इज 4 3 12. सो टोटल 12 सेंट्रॉइड्स विल बी देयर. सो दिस इज हाउ वी डू इट. वी विल फाइंड आउट द सेंट्रॉइड ऑफ ऑल these, and these will become the new centroid assignments for the second iteration. So in the similar way, we will now, there will be no zero because the centroid have been recalculated. So this is how again we will see that we will again calculate the distance from the centroid for every instance, and then we will see that this is cluster 1, this will go to cluster 1, this will go to 2, this will go to 3 and so on. And then again the centroids will change, and then we will see that just on after the first iteration, we will see that the membership of the clusters have not changed. None of the membership of the cluster has changed. कोई भी change नहीं हुआ. In the cluster 1 there are 1, 5, 6, 7 records only. In cluster 2 again there are 2nd and 8th record, and in cluster 3 again there is 6th, 3rd, 4th, 9th and 10th record. So none of the cluster assignment has changed. So therefore the next step is a very important step. तो यहाँ से हम सिर्फ theory नहीं करें, we are also actually looking into the implementation, जो आप वहाँ पर आपको repeat हो जाएगी और you can revise it. So ये these are all the cluster assignments. Now let us look at this table. So एक और चीज यहाँ पर हम नोट कर सकते हैं कि we can get different results with different seat records. But before this, let us look at this table. So what does this table mean? This table gives us within cluster and between cluster distance. So ये हमें बता रहा है कि cluster 1 का cluster 1 के साथ distance इतना है, cluster 1 का cluster 2 के साथ distance इतना है. तो आप you must be wondering that how is it possible that cluster 1 का distance भी है cluster 1 के साथ. So we will get back to this point. So cluster 1 का distance, this is the distance between cluster 1 and cluster 2. This is the distance between cluster 1 and cluster 3. This is the distance between cluster 2 and cluster 2. And this is the distance between cluster 3 and cluster 3. So this is the, so if I plot these clusters here, let us see. Suppose I do, this is cluster 1, this is cluster 2, and this is cluster 3. And suppose this is the centroid, and suppose for this, this is the centroid, final centroid. This I'm talking about not the initial centroid, but I'm talking about the final centroid. And suppose this is the final centroid for cluster 3. Then by this 2.89, I mean that this is the error within this cluster 1. So this is the distance or the deviation. This I can call as this is the deviation within this cluster 1. Because if it is equal to 0, then there is only one object in this cluster. And because there are many objects within this cluster at a certain distance, so therefore that this distance has to be there. So the meaning of this distance is that this is the intra-cluster distance, because this is between cluster 1 and cluster 2. This is the intra-cluster distance. This is the deviation within the cluster 2. And this is the deviation within the objects of cluster 3. This is the distance of all these, or some of the object must be lying here, some of the object must be lying here, some of the object must be lying here. So this is the distance of the objects of every instance from the centroid of cluster 3. So now you will be wondering, or you must be wondering, that what is the use of it. So this will actually help us to make a understanding, or to develop an understanding on the fact which we have said just in the beginning of the session, that the intra-cluster similarity should be minimum. Within cluster similarity should be minimum. It should not be 0, because if it is 0, this means there is only one object in the cluster. So it should be minimum. The objects of the cluster have to be closer to each other. It is not that there is only one. If there is only one, or yes, or, of course it is also possible, then this can be, this distance between cluster 1 and cluster 1 can be 0. So actually we have to minimize it. So now you can see in this whole table, you can observe a fact that all these distances are minimum. Can you see this? All these distances are minimum. However, the distance between cluster 1 and cluster 2, or the distance between cluster 1 and cluster 3, or the distance between cluster 1 and cluster 3 here, these are all comparatively larger than the within cluster similarity. So the objective of saying this is that this is within one cluster, and this is the distance between one objects of one cluster, and this is intercluster similarity, and that was the intracluster similarity. So this all depicts, all these are the intercluster similarity, and this is the intracluster similarity. Now I also have the theory of how do we calculate these functions, or these values 2.89 or 1.87 or 5.51 or 14.17 in the subsequent slides. But if we will get onto all this stuff, we'll be losing some of the very important information that we are going to learn in the implementation. So let us move to the implementation of clustering algorithm using WEKA directly from here, because we just had the idea of what is the significance of the intercluster similarity, intercluster dissimilarity, and the intercluster similarity. So let us now move on to the implementation of the clustering algorithm using WEKA. So let us start with WEKA, and let us see that how can we implement. So we do not need these here. So we will be making use of the flower iris data set again, and K means use karenge. K means clustering will be using to cluster the numerical or the continuous attributes. So classification में हमारा goal in the meanwhile this bird will get open up. In the meanwhile we have already learned that in classification our goal was to predict the class of an unknown sample after building the model with the data. But in clustering we do not know the class, so therefore our goal is to group the instances with the similar characteristics into clusters, and then after clustering we can give them the labels. So therefore let us start with the explorer. So let us, oh, because I've already said that we'll be working with the iris data set, and it is already there in the WEKA data folder. So let us start with the data set here. So this is the IRI. We are using this data set. We have chosen this data set because we already understand this data. We had already developed our understanding onto this data, that what are the input variables and what is the meaning of all the output variables here. And also we have used this data with classification. So we have a view that how the instances are going to be classified. So therefore only we are making use of this data. So this is labeled. So we will first of all unlabel it by removing the class attribute. Then we will apply clustering to group on the basis of only the input attributes, that is sepal length, sepal width, petal length and petal width. We I've already told you कि हम इसको इसी डेटा सेट को हमने इसलिए चूज किया ताकि हम इसी एक्यूरेसी को भी जज कर सके. So we have had the data with us, and then instead of this classify option, we'll simply click onto this cluster option. And then by clicking onto this cluster option, first we will have to choose the kind of the, there are a lot of number of clustering algorithms that are available on this clusterer. So we will choose the algorithm of a choice from here. So we'll simply click onto k-means clustering. So then we will click on to the k-means clustering to further configure it. So we want to display the standard deviation. So we will keep it true. And then from here, we want to make it the distance measure. We want to keep as Euclidean distance, which is set by default as a default option. So we'll keep it as it is. And then for the number of clusters, we will scroll down the generic object or editor, and then we can give the number of clusters. So Filhal, for the time being, we have no clue as to what should be the number of clusters. We have not learned yet. But because with this data, we already have a prior idea of that, yes, this data has three species, three classes, three different classes like Setosa, versicolor, and virginica. So I'm keeping intentionally, I'm keeping the number of clusters equal to 3. So with this, and then we will be using the training set, where we do not go for the percentage split or the cross validation. So we will just keep using the training set, and we will also keep this ticked to store the clusters for visualization, because we want to store the clusters for visualization purpose. Then in the ignore attributes, we will click onto the ignore attributes, because we do not want to show the clustering algorithm the last variable, that is the class variable. So by clicking on to ignore attribute, we can simply select from here the class variable, and we can select to ignore this attribute. So therefore the class variable will be ignored by the algorithm. Now, one thing we should make a note of is that k-means clustering algorithm handles missing values if there are any in the data by itself. If we are working on the numerical data, then the missing values will be filled in by the average value of all the values of the particular attribute. और मैंने आपको बताया कि हम categorical के साथ भी clustering कर सकते हैं. तो अगर हम categorical data पे काम कर रहे हैं, तो missing values will be filled in by the most frequently occurring values. And then we can simply, by setting these parameters, we can simply click on to the start. So there, by clicking onto the start button, you can see the result that has appeared in the clusterer output window. And there we can see that, first of all, we can see that the centroid of each cluster and the standard deviations for the sample values in each cluster. So इसीलिए theory में we have learned the concept of the centroid, because it is going to be there in the analysis part of the, in the interpretation part of the result of the clustering, k-means cluster analysis. So मैंने आपको वहां पर भी बताया था कि जितने भी हमारे पास attributes हैं और जितने number of clusters हैं, so we will get the centroid for each cluster with respect to every input attribute. So similarly here also we can see that the centroids are appearing for each cluster with respect to every attribute. We will come back to the discussion on the centroid and the standard deviation part, but from further from the result we can verify that k-means algorithm identified. From here we can see that the k-means identified 3 clusters of the whole data set having 61 instances in the first cluster, 50 instances in the second cluster, and 39 instances in the third cluster. If we remember or recall the previously done classification on the same data set, or if we recall the instances of the data set, we can make an assumption here that in the data set there were 50 instances each for all the 3 classes like Setosa, versicolor, and virginica. However, in these clustered instances, we can see that in one class, and there is no name given to the class right now. So in the first class, only there are 61 instances. In the second class, there are 50 instances. In the third class, there are 39 instances. However, in the original data, there were 50 instances each for every class. So to compare now the result of clustering with the actual classes, select the classes to cluster evaluation equal to, we can select the classes to cluster evaluation from here in order to see how these clusters are actually distributed, how these instances are actually distributed into the classes. So what we have simply did that, just to see the see that how these instances are actually distributed in 3 different classes, we have checked these classes to cluster evaluation. And then we can simply rerun the algorithm, and there we go. So now we can have a closer look at the output which is appearing in the window. So there we can see that the cluster 0, these are the names that are given by the WEKA. So these are the names now that are given by WEKA, and this is the confusion matrix that we have already discussed in the classification class. So the cluster 0 is the first cluster. 3 clusters are there. The first cluster is cluster 0. The second cluster is cluster 1. The third cluster is cluster 2. And the cluster 0 is named versicolor. 1 is named Setosa, and the third is named virginica. So from here we can see that this is Setosa, versicolor, virginica. These were the actual classes and these are the predicted classes. So from here we can have an idea that all, if we look at the closer look in the confusion matrix, we can see that all these instances have been correctly classified. Cluster 1 was Setosa, and this is Setosa. So all these Setosa instances, there were 50 instances each in every class, Setosa, versicolor, and virginica. So we can see that all these Setosa instances are correctly classified. And most of the versicolor and virginica are also classified correctly, but some of the versicolor and virginica got mixed up with each other. वो कैसे mix up हुए? Let us see. Like this is the class for versicolor. 0 is the class for versicolor. So 47 of the versicolor have been identified correctly, and 3 of the versicolor are identified in Virginica. So this second 2 is the class for Virginica. So 47 of versicolor have been correctly classified by the clustering algorithm, but 3 of these are wrongly classified. And how they are classified wrongly? These are not wrongly classified in Setosa, rather they are classified in Virginica. And if we look at the last sample, the 36 of the Virginica, because this class 2 is for the Virginica, so these 36 of the Virginica samples have been correctly classified, and 14 of these Virginica samples have not been incorrectly classified in Setosa, but have been incorrectly classified in this versicolor class. So this Virginica and versicolor are mixed up with each other. 3 versicolor के instances are wrongly classified in Virginica, and 14 of the Virginica instances are wrongly classified in versicolor. So this is how we look at it. But overall, by giving the number of clusters to be equal to 3, simple K-means clustering did a pretty good job of distinguishing between different flower species. So now let me raise the drawing here, and if we want to go for the visualization, so we can visualize by right clicking on the result list, by right clicking onto this algorithm, and by choosing the visualize cluster assignments, we can have a look at the pictorial representation of the same. So let us have, so from here we can change the y-axis. Suppose we want to, we can see 2 dimensions at a time. So let us have a look at the petal length, and we want to check the width, petal length on the x-axis and petal width on the y-axis. So we can also, so these are, as we can see that there are 50 instances of Setosa. This is cluster 0, this is cluster 1. So cluster 1 was Setosa. Cluster 1 was given the name Setosa by the WEKA software. So this is this red color of cluster 1 is plotted here. Cluster 0 was versicolor, so this blue is plotted here, and cluster 2 is Virginica, shown by this green color is plotted here. And we can also increase the jitter by to have more number of plots. So as you can see that there are less number of instances right now on the plot, but by increasing the jitter, we can increase the jitter to up to the maximum level to have all the instances plotted on the area. So now we can see that with this representation also, we can see that all these Setosa instances are correctly classified. But if we look at the Virginica and versicolor, some of the Virginica and versicolor got mixed up with each other. So we can also click onto some of the instance to have a broader, this instance was actually Virginica, but it has been plotted in, clustered in, wrongly classified by the clustering algorithm in versicolor. So we can see by clicking onto this particular any object, we can click on to check the dimensions of that object. So if we click onto that object, we'll have to first close the previous object. So by clicking onto this object, we can see that this is the instance number, this is the sepal length, this is sepal width, petal length, and petal width with respect to this particular object. So now the point, so we can see in visualization that Setosa is correctly classified and ended up in the right cluster, but we have got some errors with the Virginica and the versicolor. As these square boxes show the error, and this cross box, the cross is the correctly classified. So some of the square boxes are there in the part of this Virginica, and some of the square boxes and the green boxes are there in the part of versicolor. So now the point is that why are these instances incorrectly classified? You must be wondering that the data set is same, and the values of the instances with respect to the attributes are same. Only thing that we have changed is the algorithm. From classification we have changed to the clustering. Then what actually it made to wrongly classified some of the instances. So what is the reason for this? So if you recall, in classification, अगर classification का if you remember, suppose let us classify it. Let me erase the drawing first, and suppose on the same data if I classify with the help of J48 and using suppose a percentage split, and suppose if I start and if I visualize the tree, so I can make a very good observation here that the classification process is based on the concept of information gain. Whichever attribute will be giving the minimum information will contribute to the maximum information gain, and this is the attribute with the maximum information gain which is at the root attribute. So यहाँ पर हमने देखा था कि most influential attribute is the petal width, and in most of the cases 98 or 96% of the instances are just classified on the basis of just petal width, petal length, and petal width. So these all instances are just classified on the basis of petal length and petal width, and sepal length and sepal width, two of the other input attributes, were not there in the picture at all. So though they were there in the input data, though they were supplied to the data, supplied as the data set to the classifier, but classifier actually did not find these important to be a part of the decision tree or the classification process. However, on the other hand, if I erase the drawing from here and if I go back to the clustering algorithm, and if I see the instances here, so all these instances are clustered not just on the basis of petal length and petal width, but also on the basis of sepal length and sepal width. So we can see a plot here which is on the basis of sepal length and sepal width. So this is how you can see that not just on the basis of petal length and petal width, rather on the basis of sepal length and sepal width also these can be clustered. So therefore, the difference between the way the classification performed and the way the clustering performed is that the classification actually first find out that which are the most relevant attributes to be a part of the classifier. On the other hand, clustering will perform on with respect to all the input attributes. So it will take into account the petal, all the attributes like petal width, petal length, sepal width, and sepal width. So therefore, there may be a difference in their result that some of the instances can be wrongly classified. However, the accuracy, the overall accuracy of the k-means clustering algorithm is good, because most of the apart from just 17 instances, a major part of the instances are correctly classified. So this is about the difference between the, so let me raise the drawing here, and so this is about why the some of the instances are differently, I will not say incorrectly, rather differently classified or differently partitioned when we use clustering. So now comes a very important point if we come back to the result of the clustering algorithm, because yahi se ab hame we are going to get a clearer picture of that what is this sum of squared error and then we will also get to know that what should be the optimum number of clusters from here. So let us see from here that now if we look at the centroid and standard deviation, this centroid and standard deviation information actually tells us something about the quality of the clusters that are formed. So farther apart the centroids are, less will be the overlapping of the clusters, and increased and improved will be the quality of the classifier. So जितना ये centroids एक दूसरे से दूर दूर होंगे एक दूसरे के cluster के, so अब you can see यहाँ से हम ये देख सकते हैं कि ये centroid है cluster फर्स्ट क्लस्टर का, ये सेंट्रॉइड सेकंड क्लस्टर का है और ये थर्ड क्लस्टर का है with respect to sepal length. And these are the centroids of all these three clusters with respect to the petal length. And this is the within cluster deviation. This is the plus minus is the standard deviation. This is the within cluster deviation. So this standard deviation should be lower the standard deviation, the more tightly the samples in the clusters are grouped around the centroid. That is the higher is the quality of the cluster. So ये जो सेंट्रॉइड्स हैं ये एक दूसरे से ज्यादा दूर होने चाहिए, और जो ये स्टैंडर्ड डेविएशन है ये जितनी कम है उतनी ज्यादा अच्छा है. इसका मतलब जो ऑब्जेक्ट्स विद इन द क्लस्टर आर tightly grouped together. So this is how we look at it. Now let us look at इसके बारे में हम ये निकालते कैसे हैं. We have already learned in the theoretical part. So now let us look at a very important performance measure of this algorithm, that is sum of squared error. So the sum of squared within cluster sum of squared error here in this case is 6.99. So this is almost equal to 7. Now to understand the concept, let us take up the example or the error of sepal width for say sample 5. So how do we do it? Let us from here go to the edit to see the data set, and let us note the sepal width. This is the sepal width of the instance number 5. So just note the sepal width of instance number 5. Now सबसे पहले तो ये देखते हैं कि ये कौन सी क्लास में गया है. This instance belong to Setosa. हमें कैसे पता चला? क्योंकि all these Setosa instances are correctly classified. तो यहाँ से भी हम verify कर सकते हैं कि yes, that this cluster or the instance number 5 with this 3.6 sepal width actually belong to the class 1 or the class Setosa. Now let us go back to the cluster page, and here if we look at this sepal width of cluster 1 where in Setosa is correctly classified, the centroid for this cluster 1 is 3.418. So centroid is 3.418, and the value of the instance number 5 which actually belong to this cluster 1. इसी cluster का क्यों centroid? क्योंकि ये इसी cluster को belong करता है, और इसी value को क्यों देखें? क्योंकि we are watching with respect to sepal width. तो इसकी value कितनी है? The value of the sepal width as we have just seen is 3.6. So इसका centroid कितना है? 3.418, और जो value है fifth instance की जो इसी cluster में fall कर रहा है उसकी वैल्यू कितनी है? 3.6. तो एरर कितनी हुई? एरर विल बी therefore equal to 0.182. So this is how, why this is so important to understand here, because this is how you interpret your results when you use this concept in academics or when you use this concept in research. So this is a very good interpretation for your results. So iski error kitna hua? The error here is 0.182. नाउ सिर्फ एक ऑब्जेक्ट तो इस क्लस्टर में है नहीं, इस क्लस्टर में टोटल कितने ऑब्जेक्ट्स हैं? टोटल 50 ऑब्जेक्ट्स हैं, और उन सारे के सारे ऑब्जेक्ट्स की, फॉर ऑल दोस 50 ऑब्जेक्ट्स, उनकी वैल्यू विल बी समवेयर डिफरेंट फ्रॉम द वैल्यू ऑफ द सेंट्रोइड, बिकॉज if the value of those instances is equal to the value of the centroid, then that is not an independent object. इसका मतलब वो एग्जिस्ट ही नहीं कर रहा, क्योंकि वो सेंट्रॉइड पे ही कन्वर्ज कर रहा है. बट वी नो दैट देयर आर 50 इंस्टेंसेस. हमें इस एल्गोरिथम ने भी बताया है दैट 50 ऑफ द इंस्टेंसेस ऑफ सिटोसा हैव बीन करेक्टली क्लासिफाइड बाय द एल्गोरिथम. तो इसका मतलब 50 सच एरर्स आर देयर. और हमें कहां तक की स्टैंडर्ड डेविएशन अलाउड है? प्लस माइनस 0.318. तो यहां से भी हमें पता चल गया कि जो एरर और जो डेविएशन हमारा सेंट्रॉइड से विद रिस्पेक्ट टू इंस्टेंस नंबर 5 आया है, that is within the accepted range. वो हमारा within the range है. Now you can easily make out that what is the meaning of sum of squared error. इसका मतलब ये है कि if you square the error for each sample of the cluster, पहले तो आप हर क्लस्टर के सैंपल की एरर को स्क्वायर करो एंड फर्दर एड अप for all these samples in the entire data set, और फिर पूरे के पूरे 150 इंस्टेंसेस की इसी तरह से सभी एरर्स को एड अप कर दो, then you get within cluster sum of squared error for your clustering run, for your clustering algorithm. So obviously lower is the error, better is the run. जितनी एरर कम होगी उतना रन अच्छा होगा. So take a note of it, and then let's move on to see that how do we use this sum of square error to identify the optimum number of clusters. तो अब हम इस sum of square error को ऑप्टिमम नंबर ऑफ, क्योंकि यहाँ पर तो हमें ऑप्टिमम नंबर ऑफ क्लस्टर्स मालूम नहीं है, हमने क्लस्टर्स खुद लिए थे ऑन द बेसिस ऑफ द ऑलरेडी नोन कॉन्सेप्ट कि इसमें इस पूरे डेटा सेट में देयर आर 3 डिफरेंट क्लासेस. सो लेट अस, आई होप you would have understood the concept. Now let us move to see that how do we decide onto the optimum number of clusters. So for this, let me take up this diagram. So let us have a look at this diagram. So see this picture. So with this picture, you can see that the only idea, just a moment, let me fix it. Or okay, so for any other, ये तो हमें पता था कि this is the iris data set and there are 3 classes already present in the data set. So हमने number of clusters को 3 ले लिया था. But for any other unlabeled data, the question is that how to decide the optimum number of clusters. So just keep setting the number of clusters randomly, like 1, 2, 3, 4, 5, 6, 7, 8, and so on. And then observe this sum of squared error and then plot it like this. So sum of when the number of clusters were equal was equal to, when the number was equal to 1, sum of squared error was 55.6. When number was 2, it was 12.1. When number was 3, it was 7. It was 6.999 something. So we have taken it as 7. When the number was 4, the sum of squared error was 5.5. The number was 5, and so on. So the value of k and the corresponding within cluster sum of squared error can be seen here in the graph, identify the point where within cluster sum of squared error stops improving. यहाँ पर बहुत ज्यादा है, यहाँ पर improve हुई, यहाँ पर further improve हुई, but अब यहाँ पर improve तो हो रहा है obviously. अगर हम number of clusters को, if we will make the number of clusters equal to the number of instances, sum of this error will be equal to 0. But is it actually that we want? No, we have to optimize it. So we just have to look at a point. यहाँ पर there was a quite a lot improvement. यहाँ पर भी improvement हुई. यहाँ पर उसके बाद आप ये देख रहे हो कि जो improvement है वो uniform. ठीक है? अगर so this is the actual point which gives us the number of clusters. जहां पर improvement जो है वो बहुत कम होने लग जाए, जिस point के बाद the improvement in the within cluster sum of squared error starts diminishing, then this is the point where the slope appears to be flattened out sharply. इसके बाद अब ये जो slope है ये flat हो रहा है. It is not a slope, rather it is flattening. So therefore this is the point. तो हम 4 भी सिलेक्ट कर सकते हैं, हम 3 भी सिलेक्ट कर सकते हैं. तो यहाँ पर तो हमें पता है कि हमने 3 लेना है, तो इसलिए हम 3 को ज्यादा फोकस करें. 4 के बाद तो बिल्कुल ही फ्लैट हो गया. तो इसीलिए this is the point, this is the idea, or this is the way with the help of which we can actually decide that what should be the optimum number of clusters. Otherwise it is entirely up to the user that how they want to go about it. So this is the another idea. Now let us see that how can we classify the unlabeled data. So let me erase all the drawing from here and let us move back to the तो पहला क्वेश्चन तो ये है कि is it possible to apply classification on unlabeled data? Let's ponder on this question for a moment. That is it really possible to apply classification on unlabeled data? Well, the answer is yes. Of course, not directly, but first by applying clustering, and then by adding these clusters to the data set as a class attribute, and then we can obviously apply the classification algorithm. So now let's do it. So उसके लिए हमें क्या करना है? We'll start afresh and let's remove everything from here first of all. So let's go back to the Explorer. So first of all, pre-process, open iris data set. And then select no class, because we do not want this class attribute to be selected here. So we will select no class. Previously, whatever class was present in the data set, we do not want it to be a part of the process. So we have selected no class from here. And then we will just go to the filter. Remember, we are now going to the filter to choose the right filter from here. We'll go to the unsupervised and then attribute, and then we will make use of the filter add cluster, because now we want to add our clusters to the our own clusters to the data set. So after this, we'll click this add cluster to configure it. And then from here, we will choose simple k-means. This has already been selected as a default option. We'll simply click this and to set the number of clusters to be equal to because we want to make 3 clusters out of the entire data set. So we'll make it number of clusters equal to 3. Okay. And then ignore attribute indices. Yes, this is the 5th attribute, the class attribute. So we want to just ignore it. So we'll add the indices of the index of the last attribute or the class attribute that we do not want to be a part of the algorithm. We will simply click on OK. And then we will simply apply. Just see the last attribute here. So this is the attribute that we have added to the data set, which is having the information of the clusters. So this is just the attribute that we have added with the add cluster filter. To further analyze, let us look at this with the help of this edit option, and here we can see that how the cluster distribution has been done, and we have seen that it now, in spite of the 5 attributes in 4 input 1 output, we have 6 attributes, and this 6th attribute is a bit highlighted, which indicates that now yes, it is going to be used as the class attribute. If you scroll down, you can see that 17 samples are not being classified correctly, rather they are classified differently. तो वो हमें पता ही है, we have already seen the working of the k-means algorithm. So the result is same. We have just added the cluster assignments to the data set. हमने सिर्फ cluster assignments को data set पे add किया. अब हमने ये किया क्यों है? Because we wanted to apply classification to the unlabeled data. So this added cluster attribute as the class attribute. So now we will go to the pre-process and we will remove the class attribute from here. We will just remove it because we just don't want it to be here. And then we will simply go to classify tab. And because now we want to use this data for the purpose of classification, and we want to make use of the decision tree J48, which is based on the concept of information gain, and we want to make use of the percentage split. So we will accordingly set the options, and rest of the things we want to go with the default settings. We will simply run the algorithm. We will simply start. And we can see the prediction rules and observe the different from that of classification. So we can see that from here we can well understand that these some of these instances, how the instances are actually, this is the 94.1176% accuracy, and this is the confusion matrix. This is cluster 1, cluster 2. We could have named the cluster जैसे कि हमने पहले किया था, and we can see from here that these are the correctly and incorrectly classified instances. We can also see with the help of the classification rules that yes, if we recall or if we have the idea of what rules were there in case of the classification, original classification on the original data set, then we can easily make out the difference between these two implementations. We can also visually result with the help of the tree. So यहाँ पर हमने क्या देखा कि वहां पर हमने सिर्फ petal length और petal width के basis पे classification थी. Here we can see that the classification, the rest of other attributes are also kept into account, like petal width and then petal length and then sepal length and then petal length and then sepal length. So not only petal width and petal width and petal length are contributing to the classification process, but when we perform the clustering on the data first and then classification, the other attributes are also contributing to the process of classification. So this is how we can differentiate between the actual process that we did in the classification part, and now that we have done after making use of the clustering. Now we can also prune the decision tree. और pruning का मतलब क्या है कि यहाँ पर हम ये क्या देख रहे हैं कि in the leaves, in all the leaves we can see that there are minimum 2 number of instances. So ये एक leaf है जिसमें 50 instances है. If you observe it carefully, we can have a better idea of what does we mean by pruning. तो यहाँ पर 50 instances हैं और यहाँ पर इस leaf में 52 instances हैं. इस लीफ में टोटल 10 इंस्टेंसेस हैं, इस लीफ में 3 इंस्टेंसेस हैं और इस लीफ पे भी बहुत सारे इंस्टेंसेस हैं एंड इस लीफ पे 2 इंस्टेंसेस. तो इसका मतलब ये है कि फिलहाल एट प्रेजेंट द डिसीजन ट्री विल क्रिएट अ ब्रांच अगर उसको मिनिमम 2 इंस्टेंसेस भी किसी ब्रांच पे मिल गए तो द ट्री विल क्रिएट अ ब्रांच with as much as just 2 instances in a node, in a leaf node. However, pruning से क्या फायदा होता है? Pruning का क्या objective है? Pruning का objective है कि just for the sake of 2 instances, we do not just want to complicate the tree. कई बारी जब number of attributes बहुत ज़्यादा होते हैं और number of instances भी बहुत ज़्यादा होते हैं तो tree becomes a bit complicated and complex. तो उस केस में हम ट्री को प्रून कर सकते हैं. किस तरह से प्रून कर सकते हैं? लेट मी इरेज द ड्राइंग हियर. यू शुड जस्ट रिमेंबर दिस व्हाट वी हैव लर्नड हियर. और यहाँ पर भी हम देख सकते हैं कि जो ट्री है वो हमारा दिस इज व्हाट द साइज ऑफ द क्लासिफिकेशन रूल्स. बहुत सारे क्लासिफिकेशन रूल्स निकल के आए हैं और जैसे जैसे एज वी कीप ऑन इंक्रीजिंग द नंबर ऑफ input attributes, the classification rules will be increasing and the tree will become more complex. So the idea is to prune the tree. Pruning कैसे करते हैं? We will click on to J4 to configure it and then we will simply, this is the minimum number of objects. Here we can see that this is the minimum number of objects in a leaf node. तो हमने देखा था कि अगर 2 इंस्टेंस भी किसी के आ रहे हैं तो देन ऑल्सो क्रिएट अ ब्रांच. तो इसको ओवरकम करने के लिए ट्री की कॉम्प्लेक्सिटी को कम करने के लिए हम प्रून कर सकते हैं. प्रून कैसे करते हैं? We will increase the number of instances here. So let us make it 10 from 2. Let us make it 10 now, and then we need to say okay and simply we need to start. And then we can see that the accuracy is just dipped by 2% only, and this is the classification rules that we have received after the pruning of the tree. तो सिर्फ इतने से classification rules हमें pruning के बाद मिले हैं. So this is the major advantage of pruning, that we can reduce the complexity of the tree and the interpretation of the classification rules. So this is all about the clustering, and today we will also try to learn the use of the knowledge flow for the purpose of classification. So let me erase the drawing from here first, and let's go to learn the use of knowledge flow, because till now we have been working with Explorer only. So let us start with the knowledge flow. Let us see that how do we work with knowledge flow. Similarly, tomorrow we will try to work with the experimenter also. So let us see that how do we go about it. So click on to the knowledge flow tab, and then this is how the screen will appear for the knowledge flow environment. So let us try to design a classifier here. Please take a note that at the end of the session, we will be taking the screenshot. So I'll be asking you to keep your cameras on so that we can have the screenshot of the session. So the first step that we need to do is we just need to select. These are all the things that are given on the left side of the window. which is the action window actually. So from here, first of all, we need to select the data source. So for this, we need, because we want to have the ARFF loader, we will just click here and then we'll drop it here. So we first choose to have the ARFF loader on the screen. Then the next is we will go to the evaluation and then we will select the class assigner. We will see the purpose of all these functionalities like class assigner and ARFF loader later when we'll be actually configuring these. So then after class assigner, let us select the cross validation because we want our classifier to use the class validation. Then from here, let us choose the classifier. So there are a lot of all those classifiers available that were there in the Explorer also. So we want a tree-based classifier. So we will choose the appropriate classifier from here. So we want to go for the J48. We will simply click onto J48 and we'll place it in the, and then after choosing this classifier, let us again go back to the evaluation tab and the classifier performance evaluation because we want to evaluate the performance of the classifier. So let us choose to select the classifier evaluation performance evaluator and place it on the window. Then, so this is all the stuff is there. Okay, then we want to go for the visualization of our results. So visualization, there are many other different ways of visualization. So suppose first of all we want to go with the text visualization. So we'll select the text viewer and then we'll place it on the window. So now the next thing is to connect these. So first of all, let us connect this ARFF to the class assigner. The purpose of ARFF, we all know this is the attribute relationship file format, and the purpose of having this in the initial stage of the model is to load the data, because ultimately the classifier is to work on the data itself, and the most widely and acceptable format is ARFF. So this is to just provide the data set to the classifier. So this is the data. When we have this data set, we will see that a rubber band will appear here, and then we can simply from here we can drag it to the classes, and this is how it will be connected. This ARFF will be connected to the data class assigner. Now why data set here? Because from here the data actually traveled to the class assigner. So data set is actually being given to the class assigner. So now from here also the data set again will be passed to the cross validation folder. And then from the cross validation, because the data set is to be now divided into training set and test set. So first we will supply the training set to the model classifier J48, and then we'll apply to the test set to J4. So this is how we can see that first the data set is supplied from the loader to the class assigner, then from class assigner it is passed to the validation cross validation folder, and then from cross validation, because now the data is to be divided into training set and testing set, test training set. Therefore the before actually giving it to the classifier, it is divided as training and testing data. And then from this J48, to connect this J48 to the classifier performance evaluator, we will choose this batch classifier, because now the J48 output will be traveled in the batch to the classifier performance evaluator. As I've told you in the first session, that this knowledge flow, the actual advantage of knowledge flow can be exploited when we'll have to work with the incremental algorithms. So not only in batch, but in incremental basis, the data can be passed on to the classifier performance evaluator. So, but for the time being, we are giving in the batch. So therefore, a batch classifier is chosen here. And then this is the text viewer to view the output in the form of a text. This is how we will finally select it to the text viewer. So now next thing is to configure all these buttons. So first of all, ARF loader configure. So we'll just left click on this, and this is how we will supply the data. To supply the data, we will click onto just browse, and then the data will be supplied from here. And this, suppose I want to work again on the iris flower data set. So this is selected, this iris flower is selected, it is available in the WEKA data folder itself, and just OK. Now, what is this class assigner? So class assigner simply means that which attribute you want to select as a class attribute. So by default, because I've told you in the beginning only that sensible default options are already set in WEKA, but still it gives you an option to configure these. But यहाँ पर हमें configure करने की जरूरत नहीं है, क्योंकि all class the last attribute is selected as a class assigner. And then this cross validation folder, 10-fold cross validation, we want to go with the default selection. And then this J48 is also, we wish to go for the class. Okay, so everything is perfect. So now we just want to run the classifier. So for running the classifier, there are two ways to do it. Okay, it is not there. Fine. So we can see the status here also in the status bar. We can see the status, and then we can simply run the classifier. We can run this so that we have just created in the window. So we will simply click on this, and we can see that yes, the ARFF loader is finished, assigner is finished, validation folder is also finished, and this performance evaluator is done, the text viewer is also done. So this way the flow, the entire process has run, and now we can simply see the output with the help of a text viewer. So we can show the results here. So we can see that 96% is the, so this is how we can see the output of our model. We could have configured the this class performance evaluator to have a more look at a different output perspectives, but यहाँ पर हमने ज़्यादा कुछ नहीं किया है. We just went for options with the default options. So we can see this is the accuracy, this is the precision, recall, and F measure of various class, and this is the confusion matrix that will appear as a text. We can also visualize the tree. So for this, what we just need to do is that we need to select the graph viewer from here, and then we just don't want the classifier performance evaluator to in between, because we simply want to look at the tree, which will be the output of this J48. So simply from here, we just need to click onto graph, and we can connect the graph like this to the graph viewer. And then we will have to rerun because we have added an additional button. So we will rerun, and then this graph viewer is also finished. So we can simply show the, so this is there we go. We can also see it in the form of a tree, and this is the same tree as we received while working with the Explorer. So this is how we can make use of the knowledge flow, many other things we can do in knowledge flow. We can like when we evaluate the performance of different classification algorithms in experimenter, WEKA does not give us the option to create the ROC curve. ROC हमने कल देखा था क्लासिफिकेशन में, और क्लासिफिकेशन के टाइम पे एक एल्गोरिथम का ROC हमने चेक किया था. बट इफ यू वांट टू कंपेयर वेरियस एल्गोरिथम, if you want to generate the ROC curve of all these algorithms to have a better look at the comparison, then that cannot be that possible in Explorer. That can only be done in the knowledge flow. So वो भी चीजें अगर हमें कल time मिले, that also, those things we can also discuss tomorrow. So this is how we can create a classifier in the knowledge flow. So I believe that this is enough for today. So can I just ask some of you to please keep the camera on so that we can take the screenshot. So let me just close it. So, okay. Let me make some of you as a presenter. And Naveen sir, let me make you a presenter. Yes. And then Nishu ma'am. Then Puninder ma'am. And Neat. Sakshi. And then Shikha is also there. So no one is appearing on the screen. Can you just keep your cameras on? Can you keep the webcam? And then Varun sir is there. Okay. Good afternoon. Good morning, Naveen sir. How are you? So, ma'am, hello ma'am, how are you?
Hello, ma'am. I'm good. How are you?
I'm good, ma'am. So Naveen sir is also there, and Varun sir.
Good afternoon, ma'am.
Nishu ma'am is there. Hello, ma'am.
Hello, ma'am.
Good afternoon,
Shika is
ma'am.
also there. Shika is also there. Good afternoon. Good morning. And let me just. How can I? Okay, mic is
Ma'am,
on.
you should
Fine.
also on the webcam.
So, are you enjoying the session?
Yes, ma'am, a
Yes,
Yes,
lot.
ma'am. Ma'am.
Thank you. So just let me take the screenshot.
रुचि मैम अपना कैमरा ऑन करो.
Just a moment. Sakshi is there. Sakshi, your pic is blurred. Yes. Sakshi is the screenshot. So thank you so much everyone for all your, and wish you a very happy learning and have a nice day. Thank you so much. With this, I'm ending this webinar. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.